And so let's learn how the volume formulas for spheres was derived. All right, so imagine, if you will, we have filled the sphere with all these teeny tiny little pyramids. The pyramids go from the center. Here's the center of the sphere, that little red dot. There we go. It goes from the center of the sphere, and it goes out to the surface of the sphere, right? So they're from, oops, so I can pop this little thing out. Ooh, that one stays in good. Usually they all fall out. So those who are listening, watching this, we're taking a look, there we go, at the model, the plastic model. Unfortunately, you can't see that because it's not on the board. But so if we go from the center here out to the edge, we will have filled this sphere with little tiny pyramids. And those little tiny pyramids are going to represent the volume. Right? So we remember the formula for the volume of a pyramid, right, is going to be 1/3 the area of the base times the height. Right? So this is the pyramid volume. All right, so but let's think what our bases are. So notice here are the bases right here. I'll just sort of shade them in green. All right, so they're all little bases. All right, and so right here's the base as well. All right, so that is one of them is a little piece of a square, a little bit rounded at the bottom, but it's a little piece of a square. All right, if we were to put all of them together, all right, all those little pyramids, because we didn't finish filling it here, all of their little bases would be on the surface area of the sphere. So we're going to replace the base with 4 pi r squared. Right, because that is the surface area for a sphere. Right, so our base is the surface area of the sphere. Now we just need the height. Well, if you remember, our pyramids go from the edge of the circle to the center. And that, of course, is called a radius. Right, so the height here is r, the radius. Right, that's the height of the pyramids. So we're going to replace the base here with the 4 pi r squared. Interesting arrow. And we're going to replace the height. Oops, I'm going to move this little arrow out. It looks so pathetic and sad. We'll replace the height with r, the radius. And when we simplify that, we get the formula for the volume of a sphere. I'd like you to put this part here in your notes. Right, so that the derivation makes sense. If the derivation makes sense, then if you ever forget it, you can get it back yourself. Right, so the part that I want in the notes is the red handwriting. Right, so everywhere you see my handwriting, put it in. Probably put it in the volume notes if you have space. You can put it on the back of the surface area notes. If you don't, that'll work too. So the volume of a sphere is 4/3 times pi times the radius cubed. The formula is derived from the formula for the volume of a pyramid. The volume of the sphere would then be the sum of the volumes of all the pyramids. To calculate this, we would use the formula for the volume of a pyramid, namely the area of the base times the height divided by 3, or times 1/3. We take the sum of all the pyramid bases, and the sum of all the pyramid bases is the surface area of the sphere. You don't have to write this. We multiply by the height, which is the radius of the sphere, and divide by 3 because that's the formula for a pyramid. The area of the base of the pyramids is the surface area of the sphere. All right? So hopefully now the volume formula for the sphere makes sense, and you can understand why we had to do surface area first, because the volume is derived from surface area. Make sure if you went, I don't know who went to the nursery, but make sure, did everyone got that part in your notes, the handwritten part on top? So add that to either the surface area or the volume, wherever you have the most space. But just know that's for volume. When we're done, I'm going to have you staple the 2 sets of notes together because they're going to be one. Or if you turn them in separately, I'll staple them. That goes for you too, listening in YouTube land. So while the class is writing down the notes, you watching, you write down the notes as well. Because this will be a Nearpod for all the students who aren't here. All the students who are here, their presence is the Nearpod, right? So
we already get a grade for that?
Yes. So student asked, do I get a grade for it? Yes, everyone gets a grade for it. Theirs was their participation. And you watching this video, yours is your participation in doing the Nearpod. You can watch it. You only get credit once. But yeah, absolutely you can watch it. I'm entertaining. Even when I'm recording the class, I'm entertaining. I am. So everyone just heard what...
Oh yeah, I can see that.
All right, so we're going to find the volume of a sphere with a radius of 14 centimeters. This one's in your notes. All right, so all we got to do is plug in for the radius. I used 14 a lot. I must like that number. So the volume is 4/3 times pi times 14 cubed. Now, I do not know what 14 cubed is. So somebody out there is going to take out their little calculator and tell me what 14 cubed is. 744? 2,744. Now, because 14 is not divisible by 3, neither is 14 cubed. Can you multiply 2,744 by 4? So we're going to multiply that by 4. So we can simplify it a little bit. 2,744 by 4. What was it? 10,000. Pi divided by 3. And that's going to be our answer, and that was centimeters cubed.
So, Ms. Mashad, with Friday's bell work, is it okay if we put it into a fraction form instead of a decimal form?
Yes. Actually, I prefer a fraction. Really? We want to find the volume of the hemisphere with a radius of 8 centimeters. All right, so we'll calculate the volume of a sphere and divide it by 2. So here, the amount of space that the hemisphere takes up is half as much. Right? So if we take half of 4/3, half of 4/3 class is? So if you have 4/3 of a cake and you eat half of it, you're going to eat 2/3. Right? They always understand it when it's cake. So 2/3 pi r cubed, that's going to be the formula for the volume of a hemisphere. We'll just replace the radius. So the volume is 2/3 times pi times 8 cubed. This one I do know. 8 cubed is 512. So we've got 2/3 times pi times 512. Also not divisible by 3 because 8's not divisible by 3. So that's going to be 1,024 thirds. So our volume is 1,024 pi thirds. And that's all there is to it. Pretty easy, squeezy, lemon, cheesy. Oh, thank you. I forgot it on both. So this one, oh, I have it on that one. It says just on the one. This one is centimeters cubed. So we may have to stop the tape and unfortunately finish up tomorrow. I know, we have closing. Unless we finish up the tape now and then we'll just do all the closings tomorrow. So the class is going to decide, do you want to just finish up the tape and do all the closings tomorrow? Or, I think we can finish the lesson up. It doesn't, you see how long it took.
Sure, why not?
Let's see if we can finish it. All right. All right, so let's do this one. We have, what's the diameter of a sphere with a volume of 288 pi feet cubed. This one isn't in your notes, add to your notes. All right, so volume formula is 4/3 pi r cubed. All right, so we are going to replace the v with 288 pi. And we have 4/3 pi r cubed. What should we do first? Anyone at purple? That works. All right, so we'll divide both sides by pi. Then we have 288 equals 4/3 r cubed. What would be our next step? Anyone at yellow? All right, so dividing by 4/3 is the same as what, class? What's that? Give it to me as a fraction. And what is it as a fraction? What's 0.75 as a fraction? 3/4. So dividing by 4/3, because when you do that, you do it wrong, and you end up actually multiplying, because you all mess that up, is the same as multiplying by the reciprocal, so multiplying by 3/4. That will cancel out over here, leaving me r cubed. And over here, 288 is divisible by 4. That's going to go in 72 times. So we'll have 3 times 72 is r cubed. 3 times 72 is 216. That is a perfect cube. So if we take the cube root of 216, let's actually show you how to derive that in case you didn't know it was a perfect cube. All right, tell me something that divides evenly into 216. 2, all right, so that would be 108. Something that divides evenly into 108. 9 goes in evenly, so that would be 12. All right, 9 is 3 and 3. Something that goes evenly into 12. 4 and 3, and then 2 and 2. So it takes 3 buddies, right, to take a cube root. Oops. Let's finish this one up. 1, 2 comes out, 2 of them go away. 1, 3 comes out, 3 of them go away. What's left? What's been circled? 2 and a 3. So our radius here is 6. No, just 6. Radius is 6 somethings, feet. Did we answer the question?
Yes. No.
Diameter.
No.
So diameter is going to be 6 times 2 feet. So that's going to be 12 feet. There we go. All right, so I'm going to close this.